Hello everyone. So our today's daily Leetcode problem is implement queue using stacks. Okay. So we have to implement a first in first out queue using only two stacks. Okay. The implemented queue should support all the functions of a normal queue: push, peek, pop, and empty. Implement the myQueue class. We have to implement the void push int x, which pushes the element into the queue, int pop, which removes the element and returns it, int peak, it will return the top front of the queue, and boolean empty, it will return true or false whether the queue is empty or not. You must only use standard operations of a stack, which means only push to top, peak pop from top, size and is empty where operations are valid. Okay, we have to use only standard operations of stack. Depending on your language, the stack may not be supported natively. You may simulate a stack using a list or DQ as long as you use only a stack's standard operations. Okay, this is for other languages. In C++, we have stack supported natively, so we have to not use any other thing. Okay, so in this we are given a series of operations and some numbers. So myQ will initialize a myQ object because it's a class. So myQ will initialize, push will push this one, and this push will push this two. So the question is easy to understand. Now we have to think, how can we implement the queue using stack. Okay, so first we have to think that what is the difference between a stack and queue. So stack is a leaf. This means last and first out. The element which will enter last in the stack will be popped out first. Okay, and queue. This is FIFO. First in first out. The element which will comes first goes first. Okay, so actually we can represent these like that. The stack is a pile of things. So the element, imagine these are books. So the element which is coming at last will be popped out first. We cannot take any other element first because it's a stack. We have to take the topmost element and which is comes at last. Queue is like a line. This is a queue of standing people in a ticket row. So this will comes first. This will come first, and after taking this ticket, this will goes first. Now this will come. This will. So first in, first out. So this is queue data structure. Now our main problem is that in stack, if we pop out, our main problem is not to push but to pop out, because in stack if we will pop out like this. Now we have to just imagine we have to do a push operation on this stack and push 4 in it. Okay, now we will push 4 in it. Now if we pop out, now if we pop out, this 4 will popped out. But in queue, if we want to arrange this in a queue, then what should be happened? This 4 should not be at the top. This 4 should be at the bottom. Okay, understand? The element which we want to enter should be at the bottom. And similarly with these elements, like for example, we can start from beginning. Like we have to first, we have one stack and we have to push one. Okay, we will push this one. Now we have to push this 2. But this 2 should not be at the top, because if we popped out, then 2 will be popped out. But we want that 2 will be popped out at the last. So we have to take out these the elements inside the stack and put it elsewhere. Where can we put? We can use one more stack. We can use one more stack. We can copy this to this. Okay, we can move stack 1 to stack 2, and now we can and push 2 inside it, and 1 is here. Now after this operation we can again move here. So after push operation we have this stack. Actually, this by combining these two stacks, we can implement this push operation like in a queue. Now if we pop out, the 1 will be popped out, which is obviously, if we implement this in a queue, then 1 is first in and first out. So 1 will be popped. So this is our main logic behind this. Okay, the other operation peak and empty will be same. Like if stack 1 is empty, return true, otherwise false. Now we will write code. Okay, so we will need two stacks, stack s1 and stack s2. Okay, now we have to write the code for push function. Like I explained to you, we will just push copy the elements of s1 till, sorry, I am doing spelling mistakes. Okay, till the stack 1 is not empty. Just push the elements like we know how we'll push s1 dot top, and now we will pop. Okay, we have to just do this operation. Now after doing this operation, we have to push our incoming element x inside the stack, because as I said, I explained to you in this, we have to push this 2 inside our array, as we have copied previously this whole one in this. Okay, so now we have to again copy whole s2 till it is not empty. Okay, I have to call this as a function in this also. We have to push the s2 dot top in this. This is the exact manner in which. Okay, so this is our implemented push function. For pop, we have to first, because we have implemented the push function, the pop and other functions will be there. We have to return it, so we can store it in an integer k, and now we can pop it out. The first in first out will be implemented, and we can just return this k. Okay, for peak, we have to just return s1 dot top. For empty, we just have to return s1 dot empty, as if it is empty or not. It will return true or false. Okay, now we'll run this. This should run fine. Okay, we forgot to put semicolon here. Now it should run fine. Any other errors? Yes, it is giving errors. Okay, these are just typos, so ignore these. Okay, so it is accepted the sample test cases. Now we will submit this. It should be accepted as a solution. Yes, it is accepted. So it is the way to implement a queue using two stacks. We have one more method which the question has not asked to do to us. If any other day the question comes in daily read code, I will solve that by using amortized method O of one complexity. Till then, thank you everyone and have a nice day.